Good morning, students. My name is Professor Somesh Banerji, and I am from the Durgadevi Saraf Institute of Management Studies. Today, I am going to take you through a very interesting technique that we use in facility location planning. This is known as break-even analysis. Now, what exactly is this technique all about? Let me give you a little bit of an explanation on this. Supposing you want to set up a factory and you have three different locations A, B and C. Where would you set up the manufacturing facility? Would you set it up at A, where you have a certain combination of fixed and variable costs? Would you set it up at B, which has a different combination of fixed and variable costs? Or would you set it up at C? We assume, for the sake of this discussion, that the revenue that you get from selling each of the products that you manufacture, whether you manufacture it at A, B or C, will remain the same. So, let us see how we use this technique for facility location planning, break-even analysis. Now, before we get into the subject proper, there are certain things that you need to understand. When we are looking at facility location planning, when we are thinking of locating a particular manufacturing facility at location A, B or C, you need to consider the fixed costs and the variable costs. Now, what are the fixed costs? The fixed costs are the costs that you incur, for example, in buying the land, in setting up the manufacturing facility, the plant, the building, the equipment, and the other overhead costs that you might incur. How about the variable costs that you incur? The variable cost is basically linked to each unit that you manufacture. Examples of variable costs would be the labor cost per unit, or the energy consumption per unit, or the machine time per unit, or the raw material cost per unit. The sum total of the fixed cost and the variable cost gives you the total cost. From this discussion, it is clear to you that for a certain volume that we consider in this example, the fixed cost will remain constant whether you manufacture 1 unit or a million units. The variable cost, on the other hand, will vary and will increase proportionate to the number of units that you are manufacturing. Similarly, we consider the concept of total revenue. Revenue, obviously, like variable cost, will depend on the number of units that you sell. So, you have a certain sales revenue that you get from selling 1 unit, and this will proportionately increase as the number of units sold increases. So, the sales revenue will be a line which will slope upwards like the variable cost line, being 0 at the point 0 where you have sold nothing, and being a certain value x for let us say a quantity of 1 million units that you have sold. We will look at how the total cost, which is the sum total of the variable cost and the fixed cost, and the total revenue intersect to give you the break-even point, and then we will try and understand what is the significance of the break-even point. Towards the end of the lecture, I will take you through 3 variants. Once you have determined the break-even point for a particular combination of costs and revenues, you can move the break-even point to the left by altering either the fixed cost, lowering the fixed cost, keeping the variable cost and the revenue constant, or you can move the break-even point to the left by lowering the variable cost, keeping the fixed cost and the revenue constant, or the third technique would be to increase the revenue, keeping the fixed cost and the variable cost constant. We will look at all 3 techniques one by one. So, let us start with the discussion of break-even analysis. Now, in the slide in front of you, you have the x and y axis depicted. X shows the volume and y axis shows the cost. Now, the fixed cost, if you remember, I mentioned is constant for any volume that you manufacture up to a certain capacity. So, if you are setting up a unit, let us say for a manufacturing capacity of 5 million units, then the fixed costs, which is the investment that you make in the plant, building, machinery and so on, will remain constant for these 5 million units. So, the fixed cost line, therefore, is depicted as a horizontal line parallel to the x-axis and is denoted by the term FC. As I explained before, the variable cost is proportionate to the number of units manufactured. So when you manufacture nothing, your variable cost is 0. When you manufacture 100 units, your variable cost will increase proportionately. If you manufacture 1,000 units, it will increase even further, and so on. So variable cost is depicted by a sloping line starting from the origin 0, and we denote this as VC. As I explained, the variable cost and the fixed costs together give you the total cost. So what do? We take the variable cost line and we put it on top of the fixed cost line. We transpose it in this graph in order to get the total cost line. The total cost line, therefore, is a line parallel to the variable cost line, starting from the point of intersection of the fixed cost on the y-axis. We denote this as TC, which is the sum total of the fixed cost and the variable cost. Once again, students, you might remember we talked of revenue being a variable. So when we sell nothing, our revenue is 0. When we sell a certain quantity, our revenue will proportionately increase. So once again, the revenue line will be depicted by a straight line starting at origin 0, 0 for 0 units sold, and as we sell more and more units, the total revenue will increase. That's the green line you have there, which is depicted by the words total revenue. Now there is a certain point you will observe where the total revenue line and the total cost line intersect. This point is known as the break-even point. What is the significance of this break-even point? If you drop a perpendicular from this point onto the x-axis or the volume axis, you will get what is known as the break-even volume. If you drop a perpendicular from this point onto the y-axis, which is your cost axis, you will get what is known as the break-even cost. Now, why is the break-even point important? It's important because till you reach the break-even point, as you continue manufacturing and you continue selling, you will observe that the total cost line is actually above the total revenue line, which is the green line. The red line is above the green line, which means that your total cost is in excess of your revenue, and therefore this is your loss region. For all volumes that you manufacture and sell up to the point of the break-even point, you are actually incurring a loss because your total costs are higher than your total revenue. Beyond the break-even point, however, the green line is above the red line. That is, the total revenue line is now above the total cost line, and therefore this is your profit region. So for all volumes higher than the break-even volume, the company is actually making a profit. This is important because you need to understand what is the volume beyond which the company will start making a profit. And obviously it follows that the earlier you reach the break-even volume, the earlier you will start making profits. So I come now to the 3 techniques that I talked about, which will help us to shift the break-even point to the left or closer to the origin. Let us see how this can be done. The first technique is by lowering the fixed costs. So in this next graph, I show you a lower fixed cost line. That is, your fixed cost is now lower for whatever capacity you have in mind, and the other lines remain exactly the same. So you have the variable cost line, you have the total cost line, which is by transposing the variable cost line on top of the fixed cost line, and you have the revenue line, which is the green line. You will see that the break-even point has moved to the left. What is the significance of this? The significance is that the company will actually start making profits at a lower volume than before. We can achieve the same kind of result by lowering the variable cost per unit. So if you notice the variable cost line here, and therefore the total cost line, which is parallel to the variable cost line, have a certain slope. Now in the next diagram, I am going to show you how the variable cost is lowered. The fixed cost line remains what it was before, and now you see the variable cost line is a flatter line. So that means it has a lower slope. The total cost line, therefore, would be parallel to the variable cost line. We draw the revenue line as before, and we reach a break-even point which is earlier than the break-even point that we considered in the first example. Once again, the net result of this is that the company will start making profits at a lower volume, which is your break-even volume. So you have the break-even volume here corresponding to the break-even point in this diagram. You have the break-even cost, you have the loss region, and you have the profit region as before. We look at the third option. Whenever we are looking at these variants, for the sake of simplicity, in this discussion, we are keeping the other two costs constant. So in the third variant, we increase the revenue. That means whatever rate you are selling the unit at earlier, you now decide to sell it at a higher rate. So your revenue for every unit sold will be higher than before. We look at it in this third graph. So the fixed cost remains what it was before. The variable cost has the same slope as in the original example. The total cost has the same slope. But you see that the green line now is a steeper line. It has a slope which is different from the slope we considered in the earlier example. And once again, the net result of this, increasing the unit revenue per every unit sold, is that the break-even point has moved to the left, and it means therefore that you are able to achieve break-even at a lower break-even volume, and you are therefore able to start making profit at a lower volume than before. So there are three ways in which you can actually change the location of the break-even point vis-a-vis the total revenue line and the total cost line. Thank you very much.